Welcome to today's session on Web GIS applications for governance. My name is Harish C Karnatak, and I'm working with Indian Institute of Remote Sensing, ISRO, Dehradun. Today, I'll be talking about the applications of Web GIS, what you have learned during this course last 2 weeks. We are trying to share the knowledge on the different aspects of Web GIS technology. And today we will see where this technology is being used in the governance, especially in Indian context. We'll be talking about it. So today's my presentation. Basically, I will start from the brief introduction about the internet technology, and I hope my colleague must have covered this topic also. But just I will summarize, as you may be knowing that the internet technology is not a very old technology. Still, it is being considered as one of the youngest technology, and in fact the beginning of this technology was started sometime in 1960 when the Department of Defense of the United States of America has started to build a robust, fault-tolerant and distributed computer network to transfer the messages between the computer system into their defense network. In the later stage, the US backbone by the National Science Foundation sometime in 1980s time period, they have started to fund a commercial backbone led to the worldwide participation in the development of new networking technologies and the merger of many networks. Basically, it was a network of networks. So many computers basically you are connecting together, and you may be knowing that sometime 1989 time periods, the Tim Berners-Lee from European Particle Laboratory has developed a protocol called WWW protocol. After that, he developed the language called HTML, which is a hypertext markup language. And after that, after 1990 time period, the commercialization of the internet was started. And you can say last around 30 years, this technology has reached at a very high level. And in fact, today you can see the users of these technologies are around 5.1 billion people across the world. So total population is around 7.6 billion, and today you see that around 5 billion people are already using this technology. So you can still consider it is one of the fastest growing technology. And today, not for our normal messaging purpose or normal social media activity, we are using the internet for many activity, including the governance services to the citizen in the society. And when we see the distribution of the users, the majority of these users are basically coming from Asia, and then Europe, and then Africa, Latin America, North America, Middle East. You can see the distribution of the users across the world. And of course, the majority of users are coming from Asia because due to the large number of people are living in this region. So that's why we are seeing the larger share in this basically chart. So if you see the governance of this internet, how it works basically, you may be knowing that the internet basically is not owned by any single country or not by any company. So here it is basically a network of different computer network. Suppose you have a set of computers in your network and you are just connecting with the other network, then it is known as the internet. But here the normal question comes that who is the owner of this internet, basically who is guiding the entire system here. So you have to understand that the Internet Corporation for Assigned Names and Numbers, or we call it the ICANN, this is a non-profit organization which is responsible for major three things. One is called namespace in the internet, and it is called file path, internet protocol address, and domain name system. So you know that the IP address, today we are talking about the IP version 4 or IP version 6, which is known as the IP internet protocol. So who is developing these versions? Who is developing these protocols? This is basically by the ICANN. So the member of ICANN are basically different, like a technological organizations, many academic institutions, and there are many countries are partner in this particular associations. That is a international collaboration kind of organization. And the another organization which is responsible for like a standardization of core protocol like IPv4 and IPv6 is called Internet Engineering Task Force, or we call it IETF. So by seeing this slide, you can understand that the internet is not owned by a single organization or single country. It is basically basically a collaborative network kind of things where people are sharing data, information, knowledge, and using this network for many purposes. Now, with respect to the geospatial technology, or maybe remote sensing or space technology or Earth observation systems, so how you can use this technology? You know that when the information and communication technology is growing, our technology like a geospatial technology or GIS will also grow in similar way in parallel direction. So in the most traditional method of data access is through the physical data download. Generally, you know that today, suppose you want to take some data from some organizations, you think about around 10 years back, how you used to take the data. You used to basically go there physically. You used to collect some CD or DVD or maybe copy the data in the hard disk. That is called this physical data transfer from one place to another place. But you know, the last 10 years, what is happening that now physical data transfer from the like storage devices is now moving toward the data sharing through the internet, where we are using a technology called downloading or uploading of the data. What is happening there? The host organizations or data providers are hosting data into the servers, and now you are downloading this data. Or sometimes if you are interested to upload your data, share your data to with your users, so that time what you do, you upload this data to the servers, and then by accessing these servers, your users are able to access this data. But still it is known as a physical data sharing system. So physical data transfer is happening in this kind of mode. Earlier it was through a physical media, now it is through a network system, the data is being shared. This is called the traditional data sharing system. But the advanced technologies allow to get data access either through a web services or API. So now, last 10 years, we have seen that this data downloading systems are getting very popular among the users, and every time people say that you upload data there, I will download it. But you know that what is happening in this today's environment, you must be observing that during last few years, slowly the desktop computers and laptops are going out of our use. Slowly, you must be observing that most of our computation requirements are basically we are meeting through our normal smartphones. Although smartphones are having the limited computation capabilities that with respect to storage, with respect to memory, but what is happening here, still we are able to execute many of our day-to-day activities in the mobile itself. How it is happening? You know that if you think about accessing the satellite imagery through ISRO Bhuvan portal or maybe Google Maps or Bing Map, you think, suppose Google Maps or Bing Map or ISRO Bhuvan are not sharing their services as a web service or API, then in that case, if you adopt a physical or traditional data sharing system, what you have to do, you have to download this data into your local computation device, like a computer, desktop computers or laptop or mobile, and then you can use it. But here you see that here you are not following this method. What do? You simply open their website and access their web service or API and start using the data. So here you are not bothered about the size of the data. You don't know how much data they are hosting into their servers, but you are getting your services. So these are the things which are known as advanced techniques where the data is shared through the web services or APIs. And if you see, the web services are hosted in the central or distributed data servers. So some web services you are consuming or accessing from the ISRO server, some web services from the NASA server, some web services from the Google server. Then you can integrate all these services together and you can develop your own application. You must have seen some experiment during this course. My colleague Kamal was explaining how you can develop the massive architectures. You know that this is a typical data access method on which what you are doing, you are accessing the data through the web services and then you are integrating together. And another important development in this direction is happening is cloud-based computation architectures, which is again a very interesting platforms on which you are hosting your data, and then many activities of your computation like software as a service, platform as a service, and data as a service, network as a service, all the services you are getting in the clouds. You know that the clouds are basically stored into the server farms, and the users are not bothered about the data sizing, data storage, network bandwidth, and most important thing is data scalability. You don't know how much storage will be required for the future data, but here the cloud-based architectures are allowing you to scale up your system very easily, and that's why it is getting very popular these days. And the computation cloud provides a platform to serve not only data as a service, but also infrastructure, software, and platform as a service. So here, when you host your data or your services in the cloud, then all the computation component like infrastructure, software, and platform, everything is available as a service. So it is basically like you just hire the resources, use it, and then leave it. Whatever you are using, for that also on that only you have to pay here. And if you see in the governance system these days in India, we have many initiatives from the government side, like a Digital India initiative. Very interesting developments are happening here, where the electronic governance or e-governance, a word what we are frequently using in our day-to-day life, is the application of information and communication technology for delivering government services to the citizen. So this e-governance, in many areas we are using, right from your normal registration process or your payment transformation transactions, you are using the e-governance for generation of different type of certificates. And these days your degree, your marks statement, mark sheets from your universities, your colleges are available online through which you are accessing it. But what is happening in the government system, if you take the typical planning and activities of government, you know that around 90% of time the decision making and planning activities of government require geospatial location specific data. You talk about any flagship program of government India, either it's a smart city programs, it's the Amrit programs, you talk about the Manrega. So everywhere you need the geospatial data, basically data which is linked with the geographical coordinate system, where the you know that you must be using the word called geotagging. What is happening, you do any development plan in the activities in the ground, you can geotag it so that in the map, the spatial distribution of this activity I can monitor. So here, most of the government program, in fact, I can say around 90% programs, they require maps. A good quality maps can produce a good quality plan. Effective plan can be prepared here. And you know that GIS is the basically technology which will help you to develop a good maps or up-to-date map by using the satellite-based observation or satellite imageries, so that it can be effectively used for planning purpose. The governmental services are also specific to location of geography. You talk about any government flagship programs, whatever program government launched today, so it is specific to a location. So for example, suppose you are talking about the COVID-19 vaccination. So COVID-19 vaccination means, suppose you start a drive for a specific location, then you have to understand the distribution of the population there. You have to understand the distribution of hospitals, and then you have to understand the feasibility to identify the location where most of the people can easily go there and they can approach the hospital and they can easily get vaccinated. This is a typical example where the location plays a very, very important role. So today what is happening in the government system, we are talking about e-governance to G-governance. Initially, it was only the electronic governance, but now we are talking about the geographical or geospatial governance, where the geolocation will be connected with each and every activity of government activity and plans. So where the role of locations will play very, very important role here. So here that we are talking about the decentralized planning, like from the state level, block panchayat to gram panchayat level. So from ISRO side, we develop a platform called Bhuvan Panchayat, on which the local level planning, you can do it at the village level, and then on the fly, on top of the maps and in background of the satellite imageries, and these plans can be executed effectively. So this kind of decentralized planning that are being done using the online GIS or the geoportal applications. If you see the popular geoportal today, maybe some of the popular portals you must be using in your day-to-day life. For example, Google Maps. You know that this is one of the most popular mapping applications, which was launched by Google sometime in 2005 and 6 time period, and they provide a very excellent data on the global satellite imageries, maps on 2D and 3D data at the street level with various applications. Today, when Google has launched their APIs to the users, so you can develop your own application on top of the Google Maps. That is the beauty of this thing. But many times, or most of the time, you don't know how much data is available in the Google servers. So this is a typical example where successfully Google has implemented all these technologies and users are effectively using it for many applications. You must be seeing these days many commercial applications like the Swiggy, Zomato. You can see the radio cab services like your Uber or Ola. They are using all these Google Maps in the background and developing their business model. And then we have another interesting applications which is very popular as a geoportal, I can say. It's called Bing Map. This is from the Microsoft site. It's a very interesting mapping application similar to Google Maps. They provide the global satellite imageries and maps. And the strength of this geoportal is they have the good road networks and point of interest data. Another portal which is called OpenStreetMap. Again, it is available in the public domain free of cost. They provide the open and free vector data and collaborative mapping application to the users. And this project was initiated by a gentleman from UK called Steve Coast in 2004. And what he envisages that time, the true data democracy, the geospatial data or maps by the public for the public. So they provide basically a platforms where you can do the mapping activities on the fly, and in the background the data satellite imageries will be available, and you can start creating your maps, and finally you can download this map into your local computer. You can start using this map for your own projects. And similarly, another project which was basically in between, it was very famous, but these days less people are using it, called the Wikimapia. So this is a crowdsourcing approach for tagging ground information. It is the simplest methods. Basically, you can do the drawing activities, or you can identify the locations. You can map the areas by concept of the wiki. So they maintain the history of each and every update of the data sets. So this is another interesting area or portal where the crowdsourcing approach or participatory approach is implemented for creation of the geospatial data in the internet platform. ISRO has launched its very interesting portal, or we call it the geoportal, called the Bhuvan. The URL is here, bhuvan.nrc.gov.in. It is a very unique initiative by Department of Space or Indian Space Research Organization to basically to make available the Earth observation data from our ISRO satellites in the polar orbit, and then the derived information from the satellite imagery like the different themes and the maps. And these data sets are available in the multi-temporal, multi-resolution satellite data for the entire Indian regions, and we also provide thematic and disaster services to the users. We will be talking about this portal in detail in coming slide. And this is a very interesting portal where a lot of data, in fact, only for India, around 30 terabyte of data is hosted for public domain, free of cost. You can access this data. Then Map My India is another very good initiative in commercial domain by a company in Delhi called the Map My India. They are basically providing the rich point of interest and detailed maps of India on commercial basis. And in fact, last few months, what we have seen, Map My India has joined together with ISRO, and now the satellite imagery from the ISRO are basically combined with the maps from the Map My India and available to the users as an integrated service. Another initiative is called Indian National Spatial Data Infrastructure, or we call it Indian NSDI. This is an initiative by Department of Space and Department of Science and Technology. Basically, this portal is hosted by DST at nsdindia.gov.in. And what they do, they are basically providing a clearinghouse or gateway to the users. By using this clearinghouse, you can basically search for the available geospatial data with the different organizations. So, for example, if you are looking for geological maps of India, so you can search the different by using the different metadata, and then it will redirect you the server of GSI, where you can basically download or access this map. Similarly, for satellite imagery, it will redirect you to this server of ISRO. Similarly, for infrastructure layer, for base layer, it will redirect you the Survey of India servers. Like that, it's basically integration of different mapping services or mapping data for the users, and this gateway can be utilized for searching of different type of GIS maps available in the country. The Biodiversity Information System is an initiative by Indian Institute of Remote Sensing, Dehradun. So what we do here, we provide the biodiversity spatial viewer and data download utilities. Rich data contents on plant biodiversity of India is available, and through it you can download or you can access data through the web services called OGC web services. as a WMS, WFS, and WCS. And at the same time, you can also you can also perform the physical download of the data. Here we have the vegetation type map, biological richness, fragmentation map, and we have the disturbance index map for entire India. And these data sets are available in open domain. Another interesting portal is Indian Bioresource Information Network, or we call it IBIN. This is again a SDI for Bioresource of India. It is a rich data content for Indian Bioresource Information System for the distributed databases. Here, if you are looking for flora and fauna data for India, so all this data, flora and fauna, is available. You can search for plant species or animal species. All these details are available here. And a very interesting portal where, for example, suppose you are looking for any medicinal plant and you want to see the geospatial location of this medicinal plant in map. So all these informations are available. Last two sites are not up to date in my slides. I think the links are changed now, called India Water Resource Information System and GIS. These are another things which are very interesting, available in public domains. For example, IIRS provide the rich data contents for water resource of India. So in coming slide, I will be updating this URL. It is already updated, but in this here old URL is shown. And similarly for NIC, they have the village level tagging of information in GIS domain in their basically Bharat maps, and these maps are available in public domain. Now, if you talk about the governance, where the majority of government projects are basically using these data sets in their day-to-day activities, some of the major projects are highlighted here. If you talk about Ministry of Rural Development, they are using the groundwater prospect mapping projects. They are using in the watershed wasteland mapping project and monitoring activities. In the Ministry of Urban Development, they are using these portals and data set for National Urban Information System, AMRUT program, and Smart City programs. Ministry of Water Resources, they have basically many programs here. Some of the popular programs I have highlighted here, like irrigation infrastructure, command area monitoring, sedimentation of reservoirs, India Water Resource Information System, snow melt runoff, glacier lake monitoring, river configurations, flood forecasting, water resource assessment. Ministry of Agriculture, they use for the crop acreage and production estimations, or FASL, agriculture drought monitoring, horticulture monitoring. All these data sets are available in public domain through the GeoPortal application. And here they are using the WebGIS technology very effectively. And if you talk about the Ministry of Home Affairs, they are using this technology for the space-based input or disaster management support, and national database for emergency management, flood monitoring, drought, landslide, and other natural and man-made disasters. Ministry of Environment and Forests, they are using the this particular WebGIS technology for the forest cover mapping, biodiversity characterizations, wetland mapping, and so on. Ministry of Mines using for the exploration of minerals. Ministry of External Affairs, they have the specific information requirements from the different countries, also neighboring countries, and this technology is being used very effectively in their product. Now, if you talk about some of the popular e-governance programs where the geospatial technology, especially when you say that WebGIS technology or web mapping applications, some of the major projects I would like to mention here in coming one or two slides. Now you see about the agriculture, as I told you, in the agriculture domain, area and production estimation for 8 major crops. This project is operational since last 10 years. And here what we do, the in-season multiple forecasts, plus satellite data, plus agrometeorological and land-based observations. And if you wish to access these data sets in the GeoPortal platforms, either you can visit the ISRO Bhuvan portal, or you can visit the web portal or GeoPortal of the Ministry of Agriculture. There is a center called a National Crop Forecasting Center in Delhi. In the Pusa campus, it is established, and they are providing this information on a regular interval through a WebGIS platform, through which you can access the data sometimes as a physical data as well as the API and web services. Then we have the program called Potential Fisheries Zone, or we call it the PFJET forecast. It's a very interesting program, and last I think more than 20 years, this is available as operational programs. So here they're using the space-based observations in the entire Indian coastal regions. So daily fish catch alerts are being generated through the Ministry of Sciences, there is a center called INCOIS in Hyderabad, and they provide this alert to fishermen on daily basis as advisories. They identify the locations where there is a chance of good fish catch, and these alerts are generated on daily basis. And this program has impacted very greatly in the life of the fishermen. It has basically doubled the fish catch and reduced the search time by 60% and fuel cost by about 30%. By seeing this number, you can understand the total impact and with respect to commercial values under these programs, how much it was benefited. So all these advisories and alerts are available as geolocations. So you can identify the exact pinpoint or areas. You can identify where there is a chance of good fish catch on daily basis, so that they can directly reach to the locations and they can take the benefit of it. The monitoring of irrigation infrastructures, that is, I have taken as an example here. It is like, suppose the central government or state government is funding for an infrastructure, irrigation infrastructure development purpose and program, so they can monitor these activities on the fly on top of the satellite, satellite imagery and the maps. And if they use the time series satellite imagery, they can also monitor the progress of a particular project. So here successfully we have implemented this program called the EIPP. That is a basically assessment of gaps in irrigation potential created and stabilized of the ground levels. And these data sets are available, and it is not limited to the irrigation infrastructure. The same concept is being implemented or is used for many other infrastructure development program, including the national highway monitoring and so on. So this kind of things are available today, and people are using this technology called WebGIS very effectively, and they are sharing the data and the maps in the browser environment as the web applications, so that their users at the different levels, like a general citizen and then planners, decision makers, their engineers in the grounds, they can use these geoportals and they can effectively feed their information for the public. Then another interesting online platform called Drinking Water Purpose. We have a program called Groundwater Prospect Map and Zone and Recharge Sites. And these maps are available for entire India under ISRO Bhuvan Geoportals. Here you can download this map for your local areas on topography wise. You can also search state, district, and your village level also data sets, and it provides the potential zones where there is a possibility of good groundwaters. Basically for drinking purpose under Rajiv Gandhi Drinking Water Mission programs, it has improved the success rate of the bore wells and it has improved the water levels. So in this kind of initiative where this kind of maps are available for general public also through the geoportals, they can basically start exploring the map in their locality. At the same time, they can also download this map into their local computer to understand or to use this map during the geotechnical survey. Under the watershed development programs for the better productivity potential and improved livelihood, soil and water conservations, enhanced crop yields, and decrease in the fallow land. These are some benefit of these programs. So what we do here, we have provided the geoportals and mobile application to the Ministry of Rural Developments under our Bhuvan projects, so where they are effectively using this particular platform for their day-to-day project management and monitoring purpose. Another interesting area is called NR census. Maybe this term is very new for you. This is natural resource census. You must be knowing about the population census of India, which we do every 10 years. Similarly, we have another program called natural resource census. What we do in this program, by using the space-based observations, we generate the different type of thematic maps like land use, wetlands, soil, snow and glacier, geomorphology, land degradation and vegetation type map. On certain interval, we update these maps. For example, the land use, wetlands, soil, snow, and glacier, these are updated every 5 years. But some of the geological map, like a geomorphological map and lineament, all these maps we update every 15 years. But where these maps are available? These maps are available in the geoportal. So on the fly, as an interactive map, it is not like a static JPEG image. What you do, you just access the geoportal and browse this map like Google, what we are doing in Google Maps, and you can also perform different type of queries. You can make a plan on the fly. So the only thing what you require is basic understanding how to read the map. how to browse the map. If you have this basic understanding, then easily you can get information about the natural resources of India. And these around 7 theme data sets are available in our Bhuvan portal, and you can access this data without any cost. In the forestry sector, as I told you, the assessment of forest cover on 2-year cycle, you must be knowing that the Forest Survey of India is generating every second year the forest type map of India, and these data sets are available through their geoportals available in the FSI website, and you can access these maps as a atlas, you can download as a PDF, but at the same time you can also access it as a digital atlas or web GIS application. You can browse this map, you can query it, you can make a plan here, you can also do the change detections. Suppose you want to understand how the forest cover is changing in a particular areas. So 2 time period data you can keep in the geoportals, and you can use the stripping tool, and then you can see the changes in the maps. So then they also provide rapid forest mapping plus identification of the hotspot areas by using this concept of the online GIS or geospatial technology. In the snow and glaciers, monitoring of the glacier and snow cover areas, this is another very, very important activities. There are 2 important aspects. One is to get the drinking waters or irrigation water from these rivers, because ultimately if rivers are coming from glaciers, then you can assess this, you can quantify it, how much water you are going to get here. Another thing is with respect to the disasters monitoring. You know that is very important to monitor the glacial lakes and for the different type of disasters, and snowmelt runoff forecastings, input the climate change studies and all. Here, all these data sets basically are available under different R&D projects, and these data sets are also being shared through the geoportal applications. This is very, very important actually, especially for researchers or scientists. Those are basically involved in this kind of R&D activities. If we talk about the National Urban Information System, that is another interesting program by Ministry of Urban Development. What they do basically, with the help of technical support of the Department of Space, they have generated the multi-scale, like a 1:10,000 scale, 1:2,000 scale urban geospatial data to support of urban planning and infrastructure development activities. And these maps are effectively used for many the urban development programs. If you take an example of the Amrut programs, which is very, very popular program or very important flagship program of Government of India, under which many development activities are going on in the different cities. So what they do, they prepare the geospatial maps or data by using the high resolution satellite imageries, and then these maps are available to the users through the geoportal application. Similarly, similar kind of GIS platforms are being developed for the smart cities. In the smart city program also, you must be observing, if you have visited some website, these detailed maps are available as interactive maps to the users. This is the advantage of this GIS technology. Already decentralized planning at the Panchayat level, I already discussed about it. This is another interesting initiative by Department of Space, where we provide an online platform to the users for not only for geospatial data access, but also we provide the platform for asset mapping, activity planning based on the GIS maps, and implementation and monitoring, decision making and local level. So you can monitor the programs, you can monitor the projects. These all things are happening on the fly in the geoportal application. For the weather and climate, there are many such websites or web portals are available. And from ISRO side, we have the space-based weather parameters, essential climate variables, assimilation into the model for improved weather predictions, ocean state forecast, sea surface temperature, sea surface height, prediction of cyclone forecast, formation, and so on. What is available here, some is available as experimental data from the ISRO website called MOSTEC. In coming slide, I'll be discussing about it. But ultimately, the operational forecasts or alerts are available from the Indian Meteorological Department or IMD portals. So they are having a very extensive repository on the different aspect of weather and climate data sets, and they are sharing these data sets through their geoportals, where many GIS tools are available on the fly, and user can analyze this data and can understand the patterns. They can understand the alerts in better way. This is a typical examples called the R&D programs. This project is live since last 2 years. What we are doing, trying to do it. This is called Forest Fire Risk Advisory and Monitoring System, or we call it FRAMS. Under this geoportals, you know that what technology we study in this course for open layer, GeoServer, or post-GIS, post-GIS, all this technology we use here. And what we do here, online geoprocessing and modeling activities here, we try to identify the forest fire risk zones on daily basis. At least we try to give these alerts around 24 hours in advance to the forest planners, so they can keep a close watch of the areas so that they can avoid any damage or severe damage due to this forest fire. This system is developed as an automated digital workflow. We generate the advisories on daily basis using space-based inputs and ground information. And what we do, we publish this data as a maps, and finally we also disseminate the information as a geo SMS, that is a geotagged SMS. So what does it mean? Suppose there is an alert of a heavy or there is a chance of a forest fire in a particular forest division. So what will happen, and this point will be identified, and the SMS will be sent to the DFO of that particular division only. So this kind of approach is implemented here, and these portals are available here in this by using this URL. And we basically launched in 2019. So last 2 years we are trying to improve our modeling activities, and finally it will be available to the user as an operational product. This is for NUIS, as I told you, a National Urban Information System. Here 152 towns already mapped under these programs, and another 4,000 towns we are going to map under the Amrut programs. So this mapping activity is going on in parallel, but whatever data is being generated under these programs are basically disseminated to the users through this GIS technology. So users are able to access this data, and they are able to utilize this data for better planning or better decision making. This is for decentralized planning. As I told you, here the basically empowering the stakeholders for planning and governance. So different type of administrative boundaries, data, socioeconomic data, and stakeholder data sets are available, and these things are everything is integrated into geoportals. And plus mobile app is also provided here to the user for asset mapping, so that in the real-time mode you can monitor the progress of the project. This is NSGI, as I told you. In order to more effectively share the geodata, organizations may need to develop and utilize the spatial data infrastructure. And SGI is a coordinated series of agreements on technology standard, institutional arrangement, and policies that enable the discovery and use of geospatial information by users and for purpose of other than those it was created for. So this initiative is taken by Department of Science and Technology in collaboration with Department of Space. In India, the spatial data infrastructure is available from DSC site. Suppose in future, suppose you are looking for a specific map or specific geospatial data, I suggest you to visit their website and search your required data set based on the metadata available and published in the NSGI portal. ISRO Bhuvan is a very important initiative by Department of Space. It is basically initiative of ISRO for applications of Indian Earth observation data for governmental planning, researchers, and general public for information. And Bhuvan provides online geospatial platform in 2D and 3D environment for various data information services to its users. This is URL of the Bhuvan portal, and you can visit their website. And here the core component of Bhuvan are shown in top here. You can see around 8 components are there as a core component. And this is a G-governance dashboard. So by visiting these sections where my mouse is moving, you can see what are the major programs like Postal Department, Urban Survey. There are Chaman program for horticulture, Hellstrom, Prime Minister Krishi Sinchai Yojana, Clean Ganga missions. You can see how this technology is being used and how WebGIS is helping here to basically solve a specific problem of basically planners and decision makers. These are the major components here, like geo visualizations. We have the thematic applications, free data download facility, G-governance dashboard, disaster services, climate and environmental services, maps and OGC services, crowdsourcing, state portals, and ocean services. These are the major component of Bhuvan Geo portal. Inside that, you'll be getting many applications. Maybe Bhuvan is saying around more than 10,000 map layers they have already published as a web service, as a WMS and WFS and WCS to the users. So based on their requirement, they can access these maps into their own GIS project. This is a typical example of online mapping and GIS data creation. You know that when you use the web GIS technology, you can develop a online mapping platform for your users. So by keeping the satellite imagery in the background, your users can start creating the map of different geographical features. So here no specific GIS software or data sets are required at the user end. Only through the web browsers you can access these portals, and then you can start contributing in the mapping activities. And once maps are created, you can also easily download this map as a local file. So this system is available in Bhuvan. It facilitates user to download the interpreted or delineated drawing as SAFE file, and along with the customized attribute. Editing capabilities are available. The filtering based on date and extensible to theme are available here. So what you can do, you can search by themes, you can search by dates, and these maps once are available as vector maps, you can download and you can use it. Now, most importantly, when we are discussing about the WebGIS technology, you have to understand how this kind of geoportal we can develop by using this WebGIS like the OpenLayer, Leaflet, or GeoServe. So all these things are well documented here. You can understand this technology here, and then you can develop similar kind of mapping platform for your users also, if it is required in your any of your studies. This is for data archive, or we call it the NRC Open EO Data Archive. Here, different type of satellite imageries, thematic maps, ortho-rectified products, or maybe sometime the tropical cyclone, heat potentials, wind product like water fractions, snow melt, freeze, snow cover fractions. All these data sets are hosted in this portal by using this WebGIS technology. Here you can search for data. You can see the metadata like a different characteristics of this data, and then finally you can also access this data as a web service as well as physical data download. So both the things are available in this portal under the Google search. This is for thematic. You know that here, as I told you, the NR census program, natural resource census program. I was talking about the 7 themes where land use, land covers, wetland, wasteland, geomorphology, erosion, salt affected areas, urban flood. All these maps are basically created in the offline mode and then hosted into the server and published as a WMS, WFS, or WCS, and then available to the users through the portal or as well as API. So this way, the data is shared here, and please visit this section called bhuvan-noida.nrc.gov.in/theme. Under this section, you can see a lot of maps, lot of data is available in the interactive mode. When I say the interactive means, you can zoom it, you can pan it, you can query this map, and then you can generate your own plan on top of these portals. Disaster. Very important activity. You know that when any area hit by disasters, so the maps or the latest satellite imageries are very important for any rescue operation or any mitigation plan. So here the disaster management support from the space systems for this basically strengthening the disaster management in the country. There is a program called ISRO Disaster Management Support Program, or we call it ISRO DMSP. We are not a disaster management agency, we are a space agency. What we do, we provide the disaster managers the information on a specific disaster. For example, if you are talking about the flood, what we do, we basically monitor the flood through the space, and we generate the flood inundation map, flood hazard zonation map. When I say the flood inundation map, it is a near real-time mode. Suppose there is a satellite passed in today morning around 9:30 to 10:30 time period. So within 2-3 hours, we process the data and generate the inundation map. And then we disseminate this inundation map to the district collectors or maybe relief commissioner or a concerned officer through API or through web services. So that directly without physical download of data, they can start using it and they can make their own plan. Similarly, for forest fire, we are generating the forest fire alerts using the thermal sensors. And these alerts are basically disseminated through the geoportals as a web service, as a web API, or maybe sometimes as a RSS feed. We call it GIS feed. If you subscribe the GIS into your mobiles, so automatically this alert will be visible into your mobile, so that you will know that about the forest fire in your near locality. Similarly, for drought, landslides, cyclone, earthquake, all these informations are available in the portals, and portals are basically geo-enabled portals where the WebGIS technology is used for data sharing and dissemination purpose. This is an example for flood hazard zonations, how we disseminate the data to the village level. This is for groundwater prospect information system, or we call it the Bhuvan Bhujan. Under these programs, the groundwater prospect map for entire India, right now this scale is around 1:50,000 scale. Our team is working to basically to improve the quality of this map so that around 1:10,000 scale such kind of information will be available. But very interestingly, all these maps are available into the geoportal environments. What you can do there, you can access the data on the fly by using simple web browser platforms. This is for a state portal here for all the states of India. These data sets are available and we develop the portals, and this is a URL here, bhuvan.nrc.gov.in/state. So it's a customized state portal for all the states of India with various natural resources, disaster information, beside administrative boundaries and socioeconomic details. And it provides a dynamic custom print with active layer and regions. You can add your local data sets, like suppose you have the offline data sets. So you can add like as a KML file, as a raster file, as a SAFE file, as a WMS. You overlay the data here and then make your own GIS-based plan. There are many tools available in this portal called drawing tools, measure tools, area of interest. You can select WMS managers, analysis, search, custom print, and so on. During this course, we have already explained about all these features through the open layer and the leaflet. These features are available. If you integrate all these APIs together, you can develop a full-fledged portal for the geospatial data so that the effectively the user can use these data sets in their day-to-day activities. This is for integrated watershed management programs, or we call it the IWMP programs. So here the application facilitating the consolidated view of the watershed along with the support data sets aimed at the planners and general public. So here the hierarchical watershed select mechanism is implemented here, and visualization of watershed data sets, action plan, cadastral boundaries, administrative layers are available. Time series satellite data for monitoring of the progress of the programs. Suppose you have government has funded any budget for any watershed development programs, so you can monitor the progress of the programs by using the time series or temporal satellite images. So you can overlay these data set together and you can visualize the changes happening in the ground. And here the year-wise IWMP watersheds, net plan visualizations, customized Bhuvan mapper for IWMP users, administrative data providers, just view, report for watershed, state-bound district year-wise. And these are the URLs called bhuvan.nrc.gov.in/project/IWMP. So if you browse it, you can have an understanding that how this kind of platforms are being developed and how the users are taking the benefit of it. In the forestry sectors, it's basically different state forest department. Currently, Karnataka State Forest Departments, Himachal, Uttarakhand, and Himachal and Uttarakhand, they have already hosted their data set in these portals up to the forest circle and beat boundaries. The special data sets are available, and many forest planning activities can be performed directly in the web application through these web portals. This is for tourism. Some of the sites, archaeological sites in Nalanda, Badami, Hampi, Vijayawada. The details, basically maps are generated by using the GIS technology. Sometimes we also use the terrestrial photogrammetry techniques like laser scanners or like a TLS So we scan the areas with the very minute details, and then maps are created and then posted into the portals so that the public can have the understanding for the information purpose. Plus the Archaeological Survey of India or kind of organization can use this data set for different planning activities, including the giving the permission of the any construction nearby the archaeological sites and all. So this way, these data sets are available, and very interestingly, all things are available in public domain without any cost. That is the beauty of this technology. Urban growth modeling, if you are doing, so you can monitor the growth of a city. For example, suppose you want to understand, example in the Indore, Bangalore, Delhi, these major cities, how the city is growing. Maybe suppose you want to understand last 30 years, after 20 years, how things are changing in the city. So this kind of visualizations you can perform here on the fly in these portals. And here, not only visualization, you can also perform the different type of queries. I have taken one example from the Indore. You can see last 1991 onward, how the Indore city is growing. It is shown here. But same way, you can also model in future, if it continue to grow in this way, what is the conditions in after 10 years, 20 years, or 50 years? This kind of modeling also can be performed. So these portals are available. Suppose you are interested on this kind of urban growth modeling, so you please visit this URL. You will have a better understanding how basically data is shared to the users. For school children also, this WebGIS technology is being used by NCERT, especially in the MHRD. ISRO is helping them to basically to develop a portal called School Woman. Now it is a part of the geography syllabus in 9th class onward in CBSE syllabus. So what we did, basically, we digitized all the maps like annual rainfall, monsoon advances, monsoon retreat, whatever you are studying in your geography classes. And the same maps are digitized, available as a digital maps. And then we provide the WebGIS platforms. On top of it are many tools for the student to learn this GIS technology. So here, no specific software, no data sets are required at the user end. You can access this portal in your mobiles plus into your computers. So you can understand, you can learn the geography by using the digital platforms. To learn all this technology, we also have the ISRO NCERT e-learning contents on the remote sensing and GIS. These contents we have hosted in our website called elearning.irs.corp.in. So here the basics of remote sensing and GIS are available as an interactive mode. So you can study the remote sensing and GIS as per the syllabus of the geography class 9th onward in the CBSE board. All these things are implemented and available to the student community plus teachers. This is for National Biodiversity Information System. You see here, this is URL. As I told you, these are the major data sets: vegetation type, fragmentation, dissemination index, and biological richness. And plus, we have the species database on phytosociological data sets for around 16,000 sample plots for entire India. And these data sets are available through this website. This is a very interesting research project from ISRO side called the Meteorological and Oceanographic Satellite Data Archival Center, or we call it the MOSSET. What we do here, we serve the scientific community in the field of meteorological and oceanography with the related information coming from the satellite and ground-based system. So MOSSET archive data sets from the Indian satellites, namely Kalpana and INSET series of satellite. Currently, INSET 3D and INSET 3DR data sets are available. And all these data sets are free of cost. So if you register in this website, you can get this data set, you can do your R&D activities, you can understand how the data is shared to the users. Then plus, you can also do some scientific modeling activities here on this meteorological and oceanographic data sets. There are many services. It will be available to you under the study section, study material. So I'll be sharing it. So there are many activities, and continuously we are growing it. More services every year we are adding here to the users. This is for Bioresource Information Network, or called IBIN. So as I told you here, flora and fauna data sets for entire India is available as a BioResource SDI, BioResource Special Data Infrastructure, and you can access these data sets like through this portal. So if it is a map, you can search for a specific species, and then the location on this map will be shown, and you can browse and you can get the information about the location, and also you can also execute the location specific query on these portals. This is for Water Resource of India, where the many data sets like last 100-year data on surface and groundwaters are available. This is a latest URL of this website called India WRS.gov.in. In this site, if you visit, you will get a lot of data as a GIS data in the Geo portal. This is another interesting website by ISRO called Visualization of Earth Observation Data in Archival System. It is very interesting website for the students. So not only the data or platforms, under this VEDAS activity, we provide a lot of technical guidance and support to the students and researchers to basically use these data sets in this platform directly as a cloud. It is available. You can perform many scientific analysis on the fly on the geospatial data, and you can do your R&D activities, and you can also do your project activities under this program. This part is not part of this, I will skip. Yeah. Then as per the mobile technology is concerned, these days the WebGIS technology is slowly migrating toward the mobile platforms. Initial stage, we used to develop a lot of WebGIS portals and all, but now people are trying to develop mobile applications. So this is one example. Under the Amrut programs, we develop a mobile apps and server dashboard under the Amrut programs. What we do here, basically, it is a geotagging of different geographical features, especially in the urban areas, like you can say national highway, state highway, major roads, other district roads. This is for a simple example of the mapping of the road. So this way, the geotagging activities you can perform by using the mobile, and automatically it will be linked with the GIS maps available in the server, and a ready-to-use the WebGIS platform will be available to the users. This mobile app called Amrit Sankalan, and very interesting app and the Ministry of this Urban Development, they are using under this program for their geotagging activities. This is for some vehicle tracking for the health GIS purpose. So the near real time or real time data also can be integrated in WebGIS by using the mobile technology. This way it is happening. So MASAP already Kamal has explained you yesterday. So here it is an integration of different APIs, web services together and develop a single geo portal. And this is an example of a national database for emergency management portal, what we developed around 10 years back. You can search for NDM portal into your search engine. You'll get a full article on this. So here, this is a typical example where you can understand the mess-up or integration of different type of technologies successfully demonstrated here. And by using the same concept, you can develop similarly for other domain also this kind of applications. With this, I conclude my lecture here, and now you are invited to post your questions so that we will take for during the interactive session. So we'll take a 5-minute break, and then we'll start your questions and we'll start discussing on this. Thank you very much.